Hi all, very good morning. Welcome to Chandan Likes English YouTube channel. This is Joshna. In this session, I am going to discuss about modern physics chapter. So this is especially very helpful for the aspirants who are preparing for SSC, RRB, SSC, CGL and other competitive examination. So each and everything is very important, students. So from starting to ending without missing any single point. So listen carefully, and at the end of the session I am going to display the MCQs. So you must mention your answer in the comment section. Very good morning one and all. Yeah. Okay. So let's start the session. So today I am going to deal with like a modern physics. So what are the concepts related to this modern physics? Okay, so in this session we are going to discuss. Just this session is regarding modern physics introduction. So what is in this modern physics chapter? Okay, what is the difference between classical physics and modern physics? Okay, so who is the father of this modern physics? We are going to discuss. So till now what we have discussed in the earlier classes, so those classes are regarding classical physics. So classical physics means nothing but magnetism, electricity, units and measurements. Okay, so these are all comes under classic physics, and now we are going to discuss what is modern physics and what is the difference between modern physics and classical physics. Okay, very good morning one and all. Very good morning Kausalya, Priya. Okay, let's start this session. So I have told you already, so the physics which we have taught earlier, so that is not same as this modern physics, so both are different. And the things which we have discussed in the earlier session, that is regarding classical physics, and now we are going to discuss modern physics, just introduction part. Okay. So modern physics, it is a branch of physics that developed in the early 20th century. The physics which we have developed in the early 20th century, that physics is considered as what, students? Modern physics. So prior to 19th century, so listen properly, pre-19th century, prior to 1900, that means the physics which we know prior to 1900, and that physics is considered as classical physics. So know the difference, students. So at the beginning of the 20th century, the physics which we have learned, that is considered as modern physics, and prior to 1900 physics, that is considered as classical physics. Okay. So while classical physics, and one more difference is classical physics, this classical physics handles the macroscopic phenomena. What is the difference between a modern physics and classical physics is that the classical physics will handle the macroscopic phenomena. That means macroscopic means very large objects phenomena. When comes to this modern physics, so this will handle say microscopic phenomena. Microscopic means what? Very small tiny objects. Okay, very small or tiny objects, and this modern physics is going to handle such type of very tiny particles. So that may be atom or anything. Okay, in this session we are going to discuss, students. So once again I am explaining. So generally we have two types of physics. One is classical physics and one is modern physics. What do you mean by classical physics, students? So which is which we have learned prior to 1900, that is classical physics, and which got introduced in the early 20th century, that is modern physics. This classical physics will handle the macroscopic phenomena, and this modern physics will handle the microscopic phenomena. Microscopic is nothing but what, students? Very small or tiny objects. Okay. Now the primary purpose of modern physics is to explore microscopic object. So especially what, students? Atoms. So Albert Einstein is recognized as the father of modern physics. Very important. Who is regarded as the father of modern physics, students? Albert Einstein. So do you know anything about this Albert Einstein? If you know, mention your answer in the comment section. Okay. So as of now what we have discussed, students, we have two types of physics. One is classical physics, which deals with macroscopic phenomena, and the next thing is microscopic phenomena, and which will deal with this microscopic phenomena, modern physics. And who is considered as the father of modern physics, students? Albert Einstein. Do you know anything about this Albert Einstein? If you know, mention your answer in the comment section. I think you all know E is equal to mc square. What do you mean by this equation? Come on students. Okay, Albert Einstein. What do you know about this Albert Einstein? E is equal to mc square. So what is this equation known as? Mention your answer students. Hi, very good morning one and all. Okay. So next, and I have told you already, modern physics, it is going to deal with a very small or microscopic particles like atoms. And now we have to know what is atom, what is subparticle, everything we have to know in detail. Okay. Yes. Albert, father of modern physics. Okay. So I am saying an equation, E is equal to mc square. So what this equation is known as? So tell me students. E is equal to mc square. What this equation is known as, and it was given by Albert Einstein itself. So what it is, what this equation is. So tell me students, mention your answer in the comment section. And now we are going to learn what is atom. So who discovered these atoms? So atom consists of what? So now we are going to discuss. So in general we have already learnt in chemistry. So atom is nothing but atom is a very small particle. Okay, and we have even learnt the Dalton's theory of atomic theory also. The atom and subatomic particles, all matter consists of small indivisible particles called atoms. Okay, even in our atmosphere, even in our surroundings, so there exists very small tiny particles, and that tiny particles are nothing but what students? Atoms. Atoms are nothing but all matter made up of what students? Atoms. Atoms are nothing but very small tiny particles. That atoms, we cannot create it or we cannot destroy it. Okay, know this. We have already learnt about this in Dalton's theory. Atom cannot be created or it cannot be destroyed. The tiny particles, okay, all matter is composed of what students? Tiny particles, and that tiny particle is called what students? Atoms. Atoms consist of protons, neutrons and electrons. So electrons are negatively charged, protons are positively charged, and neutrons are neutral. We all know this very well. Okay. So who discovered this atom? John Dalton discovered the atom in 1808. Very important students. John Dalton. Okay, he has discovered the atom. Atom is nothing but a very small particles. How the cell? Okay, for example, cell is a small unit in our body. In the similar way, all matter is composed of smart particles, and that smart particle is called what students? Atom. That atom was discovered by John Dalton in 1808. Very important. And however, before him, a Greek philosopher named Democritus has proposed the concept of atomos. So even before him, a Greek philosopher, what is his name? Democritus. He has discovered the concept of atomos. Actually, who discovered atoms? John Dalton in 1808. But before him only, atomos, the concept of atomos was explained by Democritus. He is a Greek philosopher. Okay, so now we all know what is Dalton's atomic theory. Atom cannot be created nor destroyed. Okay, atom cannot be created nor destroyed, or it cannot be divided. Can we divide the atom, students? No, we cannot divide the atom. That means we cannot create it or we cannot destroy it. Next, atoms of the same element share the same mass and same properties. Atoms of the same element share the same amount of mass and properties, but atoms of different elements have different mass and different properties. We have already learnt about this in chemistry. Okay, so what is this Dalton's theory, students? Dalton's theory explains that atoms cannot be created nor destroyed nor divided, and atoms of same elements have the same mass and same properties, but atoms of different elements have different mass and different properties. We all know very well about this. Why? Because we have learnt in previous classes only in chemistry point of view. Okay. Next, subatomic particles. An atom consists of three main particles. We all know very well. So what are those, students? Electron, proton and neutron. What do you mean by electron? Electron. This electron is a negatively charged. Who discovered electron? J.J. Thomson. Okay. So who discovered electron, students? J.J. Thomson. Its names was given by Johnstone Stoney. So remember, very important, actually atom is composed of three particles, electrons, protons and neutrons. This electron was discovered by J.J. Thomson, but the name of that was given by who, students? Johnstone Stoney. Its mass is approximately 9.1 into 10 power minus 31 kg. And tell me the year, students, in which year electron was discovered. So mention your answer in the comment section. All of you mention your answer in the comment section, students. Very good morning. Hi Jaya Surya. So my question is that in which year electron was discovered? Who discovered electron? Actually J.J. Thomson, right? But the name of that negatively charged particle was given by whom? Johnstone Stoney. And what is the mass of that electron, students? 9.1 into 10 power minus 31 kg. So my question is that in which year electron was discovered? So tell me, students. Yeah. Each and every students. So tell me when the electron was discovered. In which year electron was discovered by J.J. Thomson? And the name of that electron was given by Johnstone Stoney. Nobody is giving answer to my question. And the students who are in the live session, please give a like button so that it will be shared to maximum student. And not only that, so tell me the year when the electron was discovered. In which year electron was discovered? Mention your answer in the comment section. I am not going to say, students, you have to mention your answer. Okay. And the next thing is proton. Proton is nothing but it is a positively charged particle. And who discovered this? Goldstein. Who discovered proton, students? Goldstein. And the name was given by Ernst Rutherford. So remember, very important, the name of the positively charged particle was given by Ernst Rutherford, but it was discovered by Goldstein. Okay, and what is the mass of the proton, students? It is about 1837 times mass of the electron. That means 1837 into 9.1 into 10 power 31 is the mass of the proton. Okay. In which year electron was discovered? In which year proton was discovered? So give me the information, students. Very good. In 1897 electron was discovered by J.J. Thomson and the name was given by Johnstone Stoney. And in which year proton was discovered by Goldstein and that name was given by Ernst Rutherford. And the mass of the proton is 1837 times the mass of electron. Remember, students, very basics and everybody must know this. Okay. In which year proton was discovered? So tell me, mention electron year, proton year, neutron year. Okay. And the last thing is neutron, students. A neutrally particle discovered by James Chadwick. Its mass is slightly more than that of a proton. Okay. So listen, students, I am explaining. So in order to get information from you, I have not displayed the like years. So try to get the information. Why are you like sitting idle? So get the information when the proton was discovered, in which year, when neutron was discovered, in which year, and electron was discovered in which year. So get the information, students. Then and there you have to get all the information regarding this. And what is the mass of the neutron, students? Mass of the neutron is slightly more than the mass of the proton. Okay, now we have known what is electron, who discovered it, who named it, and what is proton, who discovered it, who named it, and even we have known what is neutron. But I am asking you, in which year they were discovered? Tell me, students. So all of you, all are neglecting to my questions. Okay, next. Atomic models. We all know very well, even we have learnt in our chemistry also, atomic models. So what are those atomic models? Let us discuss in detail. The source highlights three significant models used to understand atomic structure. In order to understand the atomic structure, we have three models. So what are those three models, students? Rutherford's model, Bohr's model, nuclear atomic model. Okay. So nobody is giving answer to my very good Kirti. Very good. Electron 1897, proton 1970, neutron 1932. Very good. So, if you give the information, it will be helpful for you only, not for me, okay? Yes, very good. So, all of you make a note of it or make a screenshot of it. I think everybody knows that. And what is that, students? Atomic models. In order to explain the atomic structure, we have three types of models: Rutherford's model, Bohr's model, and the third one is nuclear atomic model. These are the important things. Okay. So, what this Rutherford's model explains, students? This model is also known as planetary model. It suggests a positively charged nucleus is at the center. It says that the nucleus is at the center and with electrons revolving like planets around the nucleus is nothing but what, students? Protons plus neutrons. So, what this planetary model or Rutherford model will say? How the planets revolve around the sun. In the similar way, the electrons will revolve around the nucleus. Nucleus is nothing but protons plus neutrons. The combination of protons plus neutrons will give us nucleus. Okay, the electrons are revolving. How they are revolving? How the planets are revolving around the sun? In the similar way, in this model, the electrons are revolving around the nucleus. So, this process is known as what, students? Rutherford's atomic model or planetary model. Just remember, how the planets are revolving around the sun, in the similar way the electrons are revolving around the nucleus. Okay? And the next model is Bohr's model. Proposed that electrons move in stationary circular orbits around the nucleus. What it is saying? It is saying that the electrons are revolving in a stationary orbit. That means, so remember this is as nucleus. So, these are orbits. These are considered as orbits. The electrons are revolving in a stationary orbit. So, this type of model is known as what, students? Bohr's model. And the next one is nuclear atomic model. It defined the nucleus as a combination of protons and neutrons. So, which atomic model defines nucleus is a combination of protons and neutrons, students? This nuclear atomic model. So, remember each and everything is very, very important. Why? Because you are just attempting MCQs model. So, no need of learning it in a very depth. Okay, if you know what is what, it is enough. For example, Rutherford's model, it is also known as planetary model. What is happening there, students? The nucleus will be at the center and the electrons will be revolve around that nucleus. How the planets will revolve around the sun? In the similar way, these electrons will revolve around that nucleus. So, this is Rutherford's atomic model. And the next thing is Bohr's atomic model. In this Bohr's atomic model, the nucleus will be at the center and there will be number of orbits and the electron will revolve around the nucleus in a certain orbit, in a stationary orbit, and that type of model is known as Bohr's atomic model. And finally, nuclear atomic model. So, what it is explaining, students? It is explaining that nucleus is nothing but it is a combination of proton and neutron. Got it? Okay. Next. And these are the key definitions we have to know. So, what is atomic number, what is atomic mass number, what is atomic mass unit. In detail, we have to know what is what. Atomic number, we all know the number of protons in the nucleus. Okay, the number of protons in the nucleus is considered as what, students? Atomic number. And what do you mean by atomic mass number? The number of protons plus neutrons. The number of protons plus neutrons is considered as atomic mass number. And what is this atomic mass unit, AMU? The unit used to measure atomic mass. Okay, the unit used to measure this atomic mass is what, students? Atomic mass unit. And one atomic mass unit is equal to 1.66 into 10 power minus 27 kg. Okay, did you understand what are those important definitions, students? Nothing but first is atomic number. Atomic number is nothing but what, students? The number of protons present in the nucleus. The number of protons present in the nucleus. Protons are nothing but we all know positively charged particles. And what is this atomic mass number, students? Atomic mass number is nothing but the number of protons plus neutrons present in the nucleus. And finally, atomic mass unit. The unit which is used to measure the atomic mass is considered as atomic mass unit. 1 atomic mass unit is equal to 1.66 into 10 power minus 27 kg. Clear all of you? Okay. Yeah, very good evening, good morning baby, Joseph, Bujji. Okay, next. So, today is the last date to grab offers, students. Up to 60% offers are going on in our Chandan Loix courses. So, each and every student utilize this opportunity. Any course you can get it only for 499 rupees. SSC exams complete courses are also on offers, up to 60% offers are available. Railway exams complete courses are also available on our Chandan Loix app. Bank SSC RRB combo courses are also available on our Chandan Loix app. Bank exams complete course, prelims placement complete courses are also available on our Chandan Loix app. 0 to Hero complete courses are available. APPSC, TGPSC, SI Constable complete courses are also available on our Chandan Loix app. Today is the last date to grab this opportunity, students. Up to 60% offers are going on. Any subject you can get it only for 499 rupees. SSC CGL special batch complete courses are also on Chandan Loix app. Telangana High Court recently has released 859 vacancies, right? So, complete updated content syllabus is available on our Chandan Loix app. Telangana SI and Constable, even 14,000 plus vacancies are yet to be released. So, each and every student grab this opportunity while offers are going on. RRB Group D complete special batch is also available on Chandan Loix app. So, next, isotopes, isobars and isotones. So, listen properly, students. Okay. So, what do you mean by isotopes? Isotopes are nothing but, for example, take an example. Hydrogen have 3 types of isotopes. That means, those isotopes consist of same number of protons but different number of neutrons. That means, they are having same atomic number but different mass number. For example, take the hydrogen. Hydrogen has 3 types of isotopes. What are those? Protium, deuterium and tritium. So, how the structure will be, students? Protium. So, this protium will consist of 1 proton plus 1 neutron, and this like deuterium consists of 2 neutrons, and when comes to this tritium, it consists of 3 neutrons. Okay, these are the structures of those protium, deuterium and tritium. So, what you can observe here, students? So, both 3 of them consist of same number of protons but different number of neutrons. That means the nuclei which consist of same atomic number but different mass number. So, those are considered as what, students? Isotopes. So, next one are isobars. So, what are those isobars, students? Nothing but same mass number but different atomic number. Same mass number. That means they are having same number of neutrons but different number of protons. So, those are considered as isobars. Example, calcium and potassium. And finally, isotones. Isotones are nothing but nuclei having same number of neutrons. Nuclei having same number of neutrons but different atomic numbers. Example, chlorine and argon. Very important concept, students. Isobars, isotones and isotopes. Isotopes are nothing but what, students? Having same atomic number but different mass number. Example, hydrogen isotopes. And isobars are having same mass number but different atomic number. And finally, isotones having same number of neutrons but different atomic number. Okay, very important concept, students. So, make a note of it or make a screenshot of it. Very important. Next, cathode, anode and X-ray. This is also very important concept in our modern physics. Okay, so let us discuss this also. Cathode rays, fast moving electrons traveling in a straight line, they are also called electron beams. So, cathode ray experiment. So, what are these cathode rays? They are nothing but they are the fast moving rays, so which travel in a straight line in a what do you mean? Cathode ray. In a cathode ray tube, if the electron beams are traveling in a straight line, so that type of beams are considered as what, students? Cathode rays. They are fast moving and straight moving rays. Nothing but electron beams. Okay, so they travel at 1/10th of the velocity of light. What do you mean by velocity, students? Velocity of light is nothing but 3 into 10 power 8 meters per second. That means they move 1/10th 1/10 of that speed. They travel at 1/10 of the velocity of the light and are used in TV tubes and computer displays. So where these cathode ray tubes are used, students? In TV tubes and computer displays. Very, very important. So what do you mean by cathode rays, students? Cathode rays are nothing but they are fast and straight moving rays. So they are nothing but the straight moving electron beams. So especially where we will use this cathode rays? In TV tubes, in computer displays. So what is the velocity of this cathode ray, students? 1/10 of the velocity of light. We all know velocity of light is nothing but 3 into 10 power 8 meters per second. Okay. Next, anode rays. Fast moving positively charged particles known as canal rays. So they were discovered by Goldstein. Very, very important. Okay, what is this anode rays? They are the fast moving positively charged rays. So how they will move, students? They are also known as canal rays and they were discovered by Goldstein. Goldstein, he also discovered proton and the name of that proton was given by Ernst Rutherford. Remember the difference. And the next one is X-rays. X-rays, they are produced when cathode rays strike a heavy metal target. Okay, who discovered X-ray, students? Röntgen in 1895. They travel at the speed of the light. So remember, what is the difference between cathode rays and X-rays? So when the cathode rays hit at a very heavy metal, remember, listen properly. When the cathode rays, they hit at a very heavy metal, so those are known as what, students? X-rays. Okay, when the cathode rays are emitted at a very heavy metal, so the rays which are emitted are known as what, students? X-rays, and these X-rays was discovered by Röntgen in 1895. Okay, so how the speed of these X-rays will be? So the speed of the X-rays is equal to the speed of the velocity of light. That is nothing but 3 into 10 power 8 meters per second. Okay, they are used to detect bone fracture and in crime investigation. So we all know. So when we go to the hospital or test lab, so they will do X-ray. That X-ray is nothing but, so they will show us where the bone is fractured. Okay, these X-rays are nothing but when the cathode rays hit very heavy metal, then these X-rays are emitted. Know the difference, students. Very, very important. Okay. Yes, very good, very good. Next, radioactivity. Nothing but, what do you mean by what do you mean by radioactivity? When an unstable nuclei emits radiation. When an unstable means that is not having the proper protons and neutrons. So that is considered as unstable. That means it is not remaining at its position. When an unstable nuclei is emitting radiation, that type of radiation is known as what, students? Radioactivity. Okay, typically occurring in elements with an atomic number greater than 83. So remember, very, very important, the elements which are having atomic number greater than 83. So these will have unstable nuclei. So these will emit radiation and that radiation is known as what, students? Radioactivity. So very, very important concept, students. I am explaining you in a very clear manner. So listen properly. Okay, atomic numbers which are greater than 83. So these atomic numbers which are having 83 elements, so these elements will have unstable nuclei. As it is having unstable nuclei, so they will emit radiation. So they will emit radiation and this radiation is known as what, students? Radioactivity. Like uranium, okay, thorium. So these are the radioactivity elements, you all know. Okay. Natural radioactivity was discovered by Henry Becquerel. So who discovered this radioactivity, natural radioactivity, students? Henry Becquerel. While artificial radioactivity like the discovery of radium was pioneered by Madame Curie. Natural radioactivity was discovered by Henry Becquerel and artificial radioactivity, for example, the discovery of radium was done by whom, students? Madame Curie. Next, units. The SI units of Becquerel are, other units include the Curie and Rutherford. So what are the units of this radioactivity, students? Curie or Rutherford. Each and every point is very, very important, students. So listen carefully. Okay. Next, particles. So how many particles, how many types of particles we have? Alpha particles, beta particles and gamma particles. So what are those? Let us discuss. Radiation consists. So we all discussed what is radiation, how this radiation emits. So nothing but the elements which are having atomic number greater than 83. So these will emits from radiation, and this radiation is considered as what students? Radioactivity. And this radioactivity will consist of some particles like gamma, beta and alpha particles. Okay. So what are those alpha particles, students? Positively charged particles, and these beta particles are, it may be positive or negative, and finally gamma particles are neutral particles. Okay. Next, application, where we will use these particles. For example, cobalt 60. So cobalt 60 is a radioactivity element. Okay, these elements are having the atomic number greater than 83. So this cobalt 60 is used to kill the cancer cells. And finally, carbon dating determines the age of fossil fuels. We all know what do you mean by fossil fuel, students. So long back ago, so which are decomposed under the soil. So those are considered as what, students? Fossil fuels. Example, coal. Okay, how the coal is produced, students? So the trees, when the trees which are gone into the earth long back ago, so they will turn into coal, and that is considered as what, students? Fossil fuel. Next, uranium dating. It determines the age of the earth or rocks. So this uranium, it is also one of the radioactive material. So what is the atomic number of uranium? All of you mention your answer in the comment section. Very, very good morning, Bhavana. Next, nuclear fission and nuclear fusion. I think everybody know this process. What do you mean by nuclear fission? The process where a heavy nucleus splits into two smaller nucleus. It is a big nucleus. When a nucleus split into two smaller nuclei, so this process is considered as what, students? Nuclear fission. Okay, fission is nothing but a big object is splitting into two smaller objects. A big nucleus is splitting into two smaller nuclei. That process is known as nuclear fission. It was discovered by Otto Hahn and Strassman. The atomic bomb is a primary example. What is the best example for this atomic bomb? So what is the best example for nuclear fission, students? Atomic bomb. So what is happening, students? So atomic bomb, so when we throw a atomic bomb, so what happens, students? That big nucleus, it is splitting into small nucleus. Again that small nucleus again splitting into 4 nucleus. In this manner atomic bomb is used. Okay, what do you mean by nuclear fission process? A big nucleus is splitting into 2 smaller nuclei, and again that nucleus is splitting into 2 other nuclei, and that is continued. That type of process is known as what, students? Nuclear fission. And what is a perfect example for this? Atomic bomb. And who discovered this? Otto Hahn and Strassman. Okay. Next, uranium-92, very good. Nuclear fission, the process where lighter nuclei combine to form a heavy nucleus. So 2 nucleus, these are very light. 2 nucleus, these are very light. So these both combine to form a bigger nucleus. So reverse of this, that is considered as what, students? Nuclear fusion. This occurs at very high temperature and is the energy source for stars and sun. The hydrogen bomb is an example for nuclear fusion. Atomic bomb is an example for nuclear fission. Hydrogen bomb is an example for nuclear fusion. And even sun and stars is also example for nuclear fusion. Okay. At very high temperature, the very light nuclei is joining to become a bigger nucleus. So that type of process is known as nuclear fusion. Example, hydrogen bomb, even sun and stars also. Okay. Next, photoelectric effect, very, very important. Okay, in modern physics, so the concepts which we are discussing, they are just the introduction part. So no need to discuss in depth about this chapter. Why? Because we just need the introduction of modern physics. So the phenomena of photoelectric machine was discovered in 1887 by Heinrich Hertz. You all know Hertz. Who is this Hertz, students? SI unit of frequency is Hertz. So even this person has discovered this photoelectric effect in 1887. During his electromagnetic wave experiment, in his experiment investigation on the production of electromagnetic waves by a means of spark discharge, Hertz observed that high voltage sparks across the detector loop were enhanced when the emitter plate was illuminated by ultraviolet from an arc lamp. So he has conducted an experiment. From this experiment, he has generated a electromagnetic wave from what? From a spark discharge. Okay. So light shining on the metal surface. So how facilitate the escape of free? Okay. So no need to discuss much more about this. Next, semiconductor electrons. What do you mean by semiconductor electrons? We all know. So as of now, so most of the electrons, they will use semiconductor chips. Semiconductor is nothing but what, students? Which behave as both as conductor as well as insulator. Which behaves both as conductor as well as insulator. That means it is conducting the electricity between a conductor and an insulator. Semiconductor, what is the function of this semiconductor, students? What is the working principle of this semiconductor? It conducts the electricity between the conductor and an insulator. Okay, it acts both as a conductor as well as insulator. So what are the perfect example for this semiconductors, students? Silicon, germanium. Okay, so mostly we will use this semiconductor chips in electronics. Semiconductor electrons is the field focus on materials like silicon and germanium with the conductivity between conductors and insulators, enabling control over electric flow. So what is the function of this? These semiconductor which control the electricity flow. Okay, this semiconductor will control the electricity flow from conductor to insulator. Next, so what are the example, students? Like in transistors, in diodes, in CPUs and in LEDs, we will use this type of semiconductors. We have two types of semiconductors, N-type extra electrons and P-type extra holes. Materials for building functional devices. How many type of semiconductors we have, students? N-type, P-type. N-type means it consists of extra electrons. P-type means it consists of extra holes. Okay. Next. So I have already explained you what is semiconductor, silicon and gallium arsenide with electrical properties between conductors and insulators. That means it conducts the electricity between metals and rubber, conductors and insulators. What are the example of these semiconductors? Silicon, germanium, arsenic, gallium. Very, very important. Okay. So doping. What do you mean by doping? Intentionally adding impurities to pure semiconductors to alter their conductivity, creating extrinsic semiconductor. Okay, in order to alter the electric flow, if we add the impurities, that process is known as what, students? Doping process. In order to convert intrinsic semiconductor to extrinsic semiconductor, what we are doing, students? We are adding impurities such that what happens? Electricity flow will be disturbed. Okay. Next, N-type. I have already told you N-type is nothing but extra electron. P-type is nothing but extra hole. Next, diodes. What do you mean by diodes, students? These diodes will allow the current to flow in one direction only. What is the function of this diode? Diodes will allow the current to flow in one direction only. What are the example? Zener diodes. Transistor. What do you mean by transistor? This acts as switches or amplifiers fundamental to all digital logic and integrated circuits. Transistors are nothing but what, students? They are switches. Okay, the off and on of the current will be based on this transistor itself. Next, integrated circuits. Chips containing millions of transistors powering computers, smartphones, TVs, etc. Next, what do you mean by solar cells? Solar cell is nothing but it is converting light energy into electricity using semiconductor junctions. Okay, you all know very well what are those solar panels. Those solar panels are utilizing semiconducting junctions for converting light energy. So, where we are getting that light energy, students? From sun. What are these solar, how the solar energy is being generated? So, the solar panels are utilizing the light from the sun and they are converting that light energy into electrical energy. For this purpose, what they are using? They are using semiconductor junctions. Okay. Next. Very good. Next, LEDs, light emitting diodes. So, they are used in lighting and displays. Okay. You all know very well LEDs. So, where we will use this LEDs, students? For displaying and for lightening purpose, we will use this light emitting diodes. They are nothing but they will allow. What do you mean by diode actually? Diode is nothing but they will allow the current to flow in one direction only. Now, tell me, students, what is the answer for this question? Each and every students mention your answer in the comment section. Yeah, tell me, students, what is the answer for this question? I have already told in the beginning of the session itself, okay, the physics which is dealing with macroscopic phenomena is classical physics and it was introduced prior to 1900s. And the physics which introduced in the beginning 20th century is considered as modern physics. It deals with the microscopic particles. Now, tell me the answer, students. Very good. Modern physics. Who is widely recognized as the father of modern physics? Isaac Newton, Niels Bohr, Albert Einstein, J.J. Thomson. Who is considered as father of modern physics? Who is considered as father of modern physics? So, tell me, students, mention your answer in the comment section. Yeah. Who is considered as a father of modern physics? Have told you already, modern physics deals with the microscopic objects. When it comes to classical physics, it deals with the macroscopic phenomena. Albert Einstein, very good. Who proposed the concept of atomos long before the scientific discovery of atoms? John Dalton, Democritus, J.J. Thomson, Ernst Rutherford. I have told you already the main thing. So, modern physics, it deals with atoms. For example, very small particles like atoms. This atom was discovered in 1808 by John Dalton. So, before him, one of the famous Greek philosopher, he has discovered the concept of atomos. So, what his name was? No. Listen properly, students. Read the question properly. Who has discovered the concept of atomos? Even before the discovery of atom was discovered by John Dalton in 1808, right? So, even before him, one of the person, he is a famous Greek philosopher, he has explained the concept of atomos. So, who is he? Very good. Very good. Baruto, something. Okay, and the answer for this question is Democritus. So, J.J. Thomson, electron, and Ernst Rutherford named the proton. And when it comes to John Dalton, he discovered atom. But atomos concept was given by Democritus. He is a Greek philosopher. Okay? Yes, very good. Next. According to Dalton's atomic theory, atoms of the same element have different mass, the same mass and properties, variable properties, no definite mass. So, we have discussed about this Dalton's atomic theory many times. So, Dalton's atomic theory states that atoms cannot be created, nor destroyed, nor divided. Atoms of same element have the same mass and same properties. Atoms of the different elements have different mass and different properties. Okay. So, we have discussed many times. And tell me, students, what is the answer for this question? Yes, tell me. Each and every students, yes, very good. So, atoms of the same mass have, atoms of the same element have same mass and same properties. Very good. Next, Which subatomic particle was discovered by J.J. Thomson? Proton, neutron, electron, positron. Yeah, tell me students. Which subatomic particles? So atoms have 3 subatomic particles like electrons, protons, neutrons, like even positron also same like a electron, but the only difference between positron and electron is what? You have to tell me the answer. Tell me. The mass will be different. Okay. Very good. Electron. So proton by Goldstein, neutron by Chadwick, James Chadwick, and positron by whom? Homework. Okay. Next question. The mass of a proton is approximately how many times that of an electron? 100 times, 500 times, 1837 times, 5000 times. I have already explained what is the mass of the electron, students. 9.1 into 10 power minus 31 kgs electron. It was discovered by J.J. Thomson in 1897. Okay, but who gave the name of the electron as electron, student? John Stone Stoney. He has given the name for a negatively charged particle as electron. Remember this. And tell me the answer for this question, students. 1837 times. Very good. Who discovered the neutron? Goldstein, Chadwick, and Rutherford, J.J. Thomson. Who discovered the neutron? And the mass of the neutron is slightly larger than that of the mass of a proton. Okay. Who discovered neutron? Neutron was discovered by, very good, James Chadwick. Okay. Rutherford's atomic model is also known as plum-pudding model, planetary model, stationary orbit model, quantum model. So tell me students, we have already discussed, I have already explained about this Rutherford's atomic model. Rutherford's atomic model is also known as what? So what happens in this Rutherford's atomic model, students? The nucleus will be in the center and the electrons will revolve around the nucleus similarly to the planets which are revolving around the sun. So tell me students, very good, planetary model. In Bohr's model, electrons move in random paths, elliptical orbits, stationary circular orbits, spiral paths. In Bohr's electron model, so what I have told students, the nucleus will be at the center and that consists of an orbit, and particular orbit consists of a particular electron, and the outermost electron is known as what, students? Valence electron, right? Okay, and that electron, so they will rotate in a stationary orbit or in a circular path or in elliptical path. So tell me students, very good. Stationary circular path. The atomic number Z represents the number of neutrons in the nucleus, protons in the nucleus, electrons in the neutron orbits, total particles in the atoms. So tell me students, what is the answer for this question? The atomic number Z represents the number of neutrons in the nucleus, protons in the nucleus, electrons in the nucleus, total particles in the atom. So tell me, I have already told you what is atomic number, what is atomic mass, what is atomic mass unit, right? So tell me the answer for this question. Very good students. Now, protons in the nucleus, atomic number is nothing but the number of protons present in the nucleus is considered as atomic number. It is denoted by Z. Okay? Yes, very good Kausalya, lucky. Very good Boruta. Okay, done. Thank you. Next, isotopes are nuclei that have the same mass number but different atomic number but different mass number of protons but different protons, number of electrons but different neutrons. I have even explained you isotopes, isobars and isotones. Isotones are nothing but what? Having the same number of the nuclei having the same number of neutrons but different atomic number. Isobars means which is having same mass number but different atomic number. Isotope means which is having same atomic number but different mass number. So tell me students, Very good. Same atomic number but different mass number. Which of the following is an example for isobars? Hydrogen 1 and hydrogen 2, calcium 40 and potassium 40, carbon 20 and carbon 14, oxygen 16 and nitrogen 16. So tell me. Isobars are nothing but which is having the same mass number but different atomic number. So I have even given you each and everything example. For example, isotope perfect example is hydrogen isotope, isobars example and isotone example also I have explained you. So tell me students, very good. Option B. The cathode rays consist of positively charged particles, fast moving electrons, neutral particles, gamma rays. Yeah, tell me students, cathode rays consist of happy birthday na? Happy birthday denki? Yeah, tell me the answer for this question students. Jan 27 kadamma, March 27, okay? And deeniki answer cheppandamma. What is the answer for this question? Cathode rays consist of fast moving electrons. Very good. Positively charged particles anedi anode. X-rays were discovered by Henry Becquerel, Wilhelm Röntgen, Madame Curie, J.J. Thomson. Speed up guys. What is the answer for this question? X-rays was discovered by. Actual ga X-rays ante enti amma? X-rays anevi cathode rays when they are hitting at a very heavy metal. So these rays will be emitted in the form of X-rays and those X-rays was discovered by Röntgen in 1895. Radioactivity occurs spontaneously in elements with atomic number greater than 50, greater than 83, less than 20, equal to 26. Yeah, tell me students, what is the answer for this question? I think all the answers are B. So in the upcoming sessions, it will not be repeated, okay? So tell me the answer for this question students. I have already explained you radioactivity is nothing but the radiations emitted by the atomic number elements which are greater than 83. Yes, which are greater than 83. The SI unit of radioactivity is Curie, Rutherford, Becquerel, Gray. The SI unit of radioactivity is, and tell me, Becquerel is the unit of which? Very good, very good. So each and every day we are having live sessions even in these channels students. So all of you at sharp 11 o'clock please join in this session also. Not only in Chandan Loik's Telugu YouTube channel, we are also conducting classes on Chandan Loik's English YouTube channel also. So each and every students, so attend to these classes also. It will be also very helpful for you. So actually Sucharita, this is complete English medium channel, okay? So we have to speak in English only. And tell me, Becquerel is the unit of what? Becquerel, it is the unit of which thing? And the answer for this question is Curie, okay? Which radiation is neutral in charge? Alpha, beta, gamma, anode rays. Which radiation is neutral in charge? Which radiation? I have already told you, radioactivity. So these emits three different types of particles like alpha particles, beta particles, gamma particles. So alpha are positively charged, beta are either it may be positive or negative, and finally gamma. So they are, tell me, gamma particles are neutral. Very good. Nuclear fission involves combining light nuclei, splitting a heavy nucleus, emission of electrons, absorption of neutrons. So I have already told you what do you mean by nuclear fission. Nuclear fission is nothing but a heavy object, a heavy nuclei. It is a heavy nucleus. It is splitting. splitting into two smaller nuclei, that is nuclear fission. Now tell me what is the answer for this question. And nuclear fission is reverse of nuclear fission. Splitting a heavy nucleus, very good. The energy source of the sun is primarily nuclear fission, nuclear fusion, chemical reaction, radioactive decay. Nuclear fission, perfect example for nuclear fission is what, students? The energy source of the sun is primarily, very good, nuclear fusion. The photoelectric effect involves electron being emitted from a metal surface when illuminated by infrared light only, light of sufficient frequency, any visible light, sound waves. So tell me, students, the photoelectric effect involves electrons being emitted from a metal surface when illuminated by, tell me. Photoelectric effect is nothing but, so there is a metal surface, when lights are strike on it, so there emits radiation. For this radiation, how much like what is being emitted from, how much illumination should be required? Light of sufficient frequency, very good. Any course you can get it only for 499 rupees, okay. Next, SSC exams complete courses are also on offers. Railway exams complete courses are also on offers. Bank, SSC, RRB complete courses are also on offers. Up to 60% offers are going on. Bank exams complete courses are also on offers. SSC, CGL special batch complete course is also on offer. Telangana High Court recently has released 859 vacancies, right? So complete updated syllabus content is available on our Chandan Loix app. RRB Group D special batch complete courses are also available on app. Telangana SI and Constable courses are also available on offers. SSC GD special batch complete course is also available on offer. RRB NTPC special batch complete course is also available. UPSC CSAT complete course is also available on Chandan Loix app. So each and every course we are giving on offers, up to 60% offer is available. Today is the last day to avail this offer. Each and every students utilize this opportunity. So each and every course, so they are, the classes are taught in both English as well as Telugu languages. So you will have examinations, even you will provide you PDFs. Okay, so that's all for today. Let's meet in the evening session, Chandan Loix Telugu YouTube channel, Maratha Empire. Okay, bye students, take care.